So this is how the imputable system works. So it works similar to the alarmable manager. I have a registration data structure to hold the commands, as well as the registration state and also the iterator reference for each of the single key event manager and as well as the keyboard event manager. And I have a pair of the ASOL key and also the event type. So that makes sense since we want to link each key to an event type. So it's called a key event, and then I have a map of key event and the registration data. So this is a map and not a multi-map since I want the key event to be unique. So each key will be bound to a specific event, so that if we have like several game objects, instead of creating a bunch of keys for, let's say, when they want to press the key enter, they'll just refer to one single key event. So that would also help to prevent duplicates. And I have the key. I have the key press callback, which is private, as well as the key release callback. Both are private, as well as the input registration and the registration functions, which are only accessible through the callback of the commands. And then the protected side, I have the submit key registration, as well as the submit key the registration. And the imputables looks like this. So I have the registration state, so that'll prevent the duplicates when I do the assert. Registration and the registration, it happens at login runtime. Since it's a multimap, we have to iterate to search for duplicates. Then here in the imputable attorney, it will give access to the single key event manager to process the correct key press and key release callback. And then for the registration, it will give access to the commands for the actual input registration and the registration in the scene. And the keyboard event manager has a map of ASOL keys and the single key event manager pointers. So I'm using a map because I want each ASOL key to be unique, and the map guarantees that. So that's the reason I'm using it. And I have on the process key event to be private, and which is only accessible to the keyboard event manager through the scene. So it's the only one who can call it. And I have the register and the register public methods, which are used by the imputable manager. So here's what the single key event manager looks like. So it has to define type lists, the key press collection, and also the key release collection, which is a list of imputable pointers. And then it also has the register and the register function. And those happen before, so it all starts within the keyboard event manager register and the register. So for the keyboard event manager, it will search for the key to whether or not has been registered already into the collection, and then it'll create a new one if there's no key already, and or else it'll just register the correct imputable to that specific key, as well as the iterator reference and the event type. And then the keyboard event manager will actually register the imputable into the correct list, whether their type is key press or key release. And that's pretty much the same for the register. And both of the register and the register use the imputable collection iterator reference. So this happens at a constant time. Then for the process key events, it will iterate through both the list, the key press and the key release collection, and then it will just call the imputable attorney to process the correct callback for either key press or key release. And this is how the documentation looks like in the Vultr Engine website. So I have the highlighted the functions, the key press and the key release callback, as well as the submit key registration and the registration, which are the user friendly. And then I have a long detailed description, as well as how to set up the key press and the key release for the enemy object. And then I have a more detailed description for each of the function, as well as some snip code for the submit key registration and the registration. And this is the actual input system diagram. It looks kind of like the alarm system. It's not as overwhelming as the update and the drawable. So let's start right here with the frigate, which has the callback for the key press and the key release, which inherits from the game object. And the game object inherits from the imputable, which has the registration data structure for each key. And then they have the registration command for within the structure, and then the commands are going to be sent to the scene attorney, and then the scene attorney will actually send it to the scene, and the scene to the scene broker. Then when it's time to execute the commands, it will call the imputable attorney for the registration callback or the registration, and then the imputable will actually register into the scene. It will first call the scene attorney, and then it's going to send the imputable instance to the correct keyboard event manager, which has a map of single key event managers. And then the imputable instance will be registered to either the key press collection or the key release collection, depending on the type that was registered. Then during the process key event, it'll just call the imputable attorney to the correct key press or key release callback, and then it will finally reach back to the frigate through the correct callback. And that's pretty much how the imputable system works.